In this chapter, we'll show you how to use the two general loop types in natural: the controlled for loop and the flexible repeat loop. The for loop is used in situations where you know up front how many iterations you want to go through. The syntax requires an iterator, which I have defined here as a 2-byte integer. I've also defined a root variable with some decimals to contain the square value of our iterator as we calculate it. So we'll write for the iterator, which is set to values from start to end, which in this case is 1 to 10. These values can be constants, like here, or variables. Let's calculate the square root using the built-in natural square root function and let it write the iterator and the root. We'll close the loop with end for. Then we'll save and run and see how the root is calculated for each of the 10 values. In contrast to the for loop, the repeat loop has more options regarding the conditions that cause it to stop running. Let's create a basic repeat loop with repeat to start the loop, a dummy statement we want executed, and the mandatory end repeat for the end of the loop. This program would be syntactically valid, but also very stupid because it would literally make natural loop endlessly. In other words, don't try this at home. Remember to specify a condition that would cause the loop to end. The repeat statement gives us two ways of doing this. The first one is the while syntax, in which you specify a logical condition, typically at the start of the loop, indicating that if this condition is not true, the rest of the loop should not be executed. I've created a Boolean, or in natural terms, a logical variable, to indicate the condition. There's a while statement at the beginning to test for this condition, a write statement to show that we are in the loop, and finally a move statement to change the variable. When I save and run this, you'll see that we only enter the loop once. The second syntax for ending a repeat loop is repeat until, where the condition is typically written at the bottom of the loop to determine whether the loop should end now or be repeated. So if I shift down the test, we'll see that the until syntax is logically formulated to be the exact opposite of the while condition. So we'll repeat until stop loop is true, and if we save and run, we once again only enter the loop once. The while and until syntax create the most structured and readable code. However, there is also a third emergency exit option, where an if statement is used in combination with the escape bottom statement to end the current loop. So let's replace the until with an if structure and add escape bottom, which can live anywhere in the loop, though this may decrease readability. So to summarize, the for loop is used to iterate through a loop a specific number of times. The step syntax lets you decrease the value or adjust the interval. Repeat while typically tests at the beginning of the loop, and repeat until at the end. Escape bottom in an if statement can be used anywhere, but is less structured.